Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math, 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 math.
Real numbers include whole numbers, rational numbers, and irrational numbers. Real numbers are not imaginary numbers.
Quadratic equations are normally expressed as ax squared plus bx plus c equals 0, where a does not equal 0. Simpler quadratic equations with rational roots can be solved by factoring.
How to factor. First, make sure the equation is in the form ax squared plus bx plus c equals 0. Then factor the left side of the equation, assuming that 0 is on the right side. Set each factor equal to 0 and solve to determine the roots. Some equations cannot be factored regularly, so you must use the quadratic formula.
The quadratic formula is negative b plus or minus radical b squared minus 4ac all over 2a. In the problem, x squared plus 4x plus 5 equals 0, a equals 1, b equals 4, and c equals 5. When you substitute these values into the quadratic formula, you get negative 4 plus or minus radical of 4 squared minus 4 times 1 times 5 all over 2 times 1. When you simplify this, you get negative 4 plus or minus the radical of negative 4 over 2. You have to make sure that you take both the positive and negative values of the discriminant. Simplifying negative 4 plus or minus radical negative 4 over 2, you get negative 2 plus I, or negative 2 minus I.
The discriminant is equal to b squared minus 4ac, and the discriminant tells you the nature of the roots. If b squared minus 4ac equals 0, then you'll have two equal real roots. When this is plotted on a graph, it will intercept the x-axis one time.
When b squared minus 4ac is less than 0, there are two complex roots. When graphed, there are no x-intercepts. When b squared minus 4ac is greater than 0, there are two unequal real irrational roots. When graphed, there are two x-intercepts.
When b squared minus 4ac is greater than 0 and a perfect square, you get two unequal real rational roots. There are two x-intercepts when this is graphed. In this problem, we are asked to find the discriminant of the equation x squared minus 3x plus 1 equals 0. In this equation, b equals negative 3, a equals 1, and c equals 1. When these values are put into the equation b squared minus 4ac, we find that the discriminant is 5.
In order to complete the square, you have to keep all terms containing x on one side. Then you move the constant to the right. Take half of the x term coefficient and square it. Add this value to both sides. Next, simplify and write the perfect square on the left. Take the square root of both sides and don't forget to take both of the positive and the negative values.
Here's an example of completing the square. In the equation, x squared minus 2x minus 1 equals 0. First, you must add 1 to both sides of the equation. Then you divide negative 2 by 2 and square it to get 1. Add this 1 to both sides. Then factor the left side of the equation to get x minus 1 squared. Take the square root of both sides of the equation, and your answers will be 1 plus radical 2 and 1 minus radical 2. In order to find the sum of the roots of a quadratic equation, use the formula negative b divided by a. In order to find the product of the roots of a quadratic equation, use the formula c divided by a.
There are three graphical situations that can result from a linear quadratic system where the quadratic is in one variable.
The equations can intersect in two locations, and there will be two real solutions.
The equations will intersect in one location, and there will be one real solution.
Or, finally, the equations will not intersect and there will be no real solution.
Substitute the value x minus 6 in for y, and you get x squared plus x minus 6 squared equals 26. Simplify this equation, and you get 2x squared minus 12x plus 10 equals 0. Next, factor the equation to get x minus 5 times x minus 1 equals 0. Your x values are 5 and 1. Then, you plug in the x values into one of the equations in order to get the y values. Finally, check your answer.
In order to solve a quadratic inequality, you must replace the inequality symbol with an equal sign and solve the equation. These solutions will allow you to decide intervals that will allow you to solve the inequality. If you want to solve the quadratic inequality graphically, first you graph the parabola. Then you choose a test point such as 0, 0 and plug it into the equation. Since the point satisfies the inequality, you shade inside the parabola.
In order to solve the inequality x squared minus x minus 12 is greater than 0, first factor the inequality to get x minus 4 times x plus 3 is greater than 0. Next, solve so that both can be positive. Therefore, x minus 4 is greater than 0 and x plus 3 is greater than 0. You are left with x is greater than 0 and x is greater than negative 3. The only condition that makes both true is x is greater than 4. Then you solve so that both can be negative. X is minus 4 is less than 0 and x plus 3 is less than 0. Therefore, x is less than 4 and x is less than negative 3. The only condition that makes both true is x is less than negative 3. Therefore, your final answer is x is less than negative 3 or x is greater than 4.
In order to solve an absolute value equation, you must isolate the absolute value on one side of the equal sign and create two cases. For example, the absolute value of a equals b, you would set this equal to a equals b and a equals negative b.
Remember to always check your answers into the original equation.
In the equation, the absolute value of x minus 10 equals 6. First, you must get rid of the absolute value and create two cases. The two cases are x minus 10 equals 6 and x minus 10 equals negative 6. Then you must solve for x in each equation, and you get x equals 16 and x equals 4. Finally, you must check both of these values into the original equation. Both of these values work, so therefore they're true.
To solve an absolute value inequality, start by isolating the absolute value on one side of the inequality symbol. Remember to create two cases. If the symbol is greater than or greater than and equal to, the answer will have the word or in it. If the symbol is less than or less than and equal to, the answer will have the word and.
In the equation, the absolute value of x minus 3 is less than or equal to 4. You must first get rid of the absolute value. Then you must create two cases, and you get x minus 3 is less than or equal to 4, and x minus 3 is greater than or equal to negative 4. When you solve this, you get that x is less than or equal to 7, and x is greater than or equal to negative 1. Because the sign in the equation is less than or equal to, you use the word and. Therefore, your answer is negative 1 is less than or equal to x, which is less than or equal to 7.
Thinking why my mathematical pi 3.14159 6535897 9323846 6433832 7.